Hi, guys. So, we're going to talk about a couple different things today. We're going to talk about section 2.4, but only part of it because there's a lot packed into that section. So, we're going to split it up into two. And so, 2.4 is about measures of variation. And remember that central tendency is about the patterns and how things are towards the middle. Variation is going to be about how things are spread out. And so I'm calling this 2.4 part A because I'm going to split it into two parts. And this week we're going to talk about this part up here, and later on we'll do those. So how to find the range, which most of you know, but then also how to find my kid, how to find the variance and standard deviation of a population and of a sample. And so first the range. This is the easy part. It's just saying you what is the difference, meaning subtract, between the highest and the lowest data entry that you got in your answers. And of course, it's going to be a number. And here it is again, your highest minus your smallest. And it's that simple. So let's do an example. We've got these two jobs, or these two companies, Corporation A and Corporation B, and it says find the range of the starting salaries for each graduate from those companies. Okay, so Corporation A, these are the salaries. Corporation B, these are salaries. So range, remember, we need to find the highest and the lowest in each of those. So the highest for Corporation A and the lowest for Corporation A, I think, are 47 and 37. And we're going to subtract those. So 47 minus 37 is 10. There we go. We found the range. Do the same idea for Corporation B. The lowest and the highest, and subtract them. 58 minus 23. So that's what this whole thing here says, right? The 47 minus 37 and the 58 minus 23. So the starting range of the salaries for Corporation A is 10 or $10,000 because this is in thousands of dollars. And hang on, my bad. And the range of the starting salaries for Corporation B is 25 or 25,000. But let's look at those two chunks of data a little bit more closely for those two companies. And I want us to look at the mean, median, and mode. Well, not the mode, sorry, the mean and the median and the range. So I went ahead and I popped those into a spreadsheet, and I found the mean, the median, and the range. I put them in order, right? Company A and Company B. And the median number was right here. The middle number was 41. And when I did the average, right, add them up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, add them up and divide by 10, you get 41.5. That's the same for both of these companies, but their range was very different. And so even though they both have the same median and the same mean or average, the data is way more spread out in Company B, so it has what's called a higher variance or a higher variation. And so it's easier to see that if we look at graphs. So if I show you the two graphs, you see how the middle information is still the same. The middle information is still the same, but this is way more spread out, and this is all kind of clustered together. And so that's what we're going to be talking about this time, is how to measure how spread out things are. And one way to do that is with the range, okay? So variation is a way to describe how spread out data is. Range, that's the easy one. And then there's going to be these two other formulas, so a little bit more complicated, but we're going to use them a lot. One's called the variance, and by itself, it's not always that helpful, but it helps us find the standard deviation. And standard deviation is just the square root of the variance, and it's super helpful. So I'm going to give you a whole bunch of formulas. You ready? On the left side is going to be all the sample version, if you're only talking about a sample, and the right side is going to be all the population version. So we're going to have deviation, which just means take every data and subtract from it the mean or the average. Then you're going to have to do some things. You're going to have to take each of those and square them and then add them up. and then divide by n minus 1. And this is what's called the sample variance. This will make more sense when we do a couple examples. And then if you just take the square root of that, then you get the sample standard deviation. Now the population version of all this is similar, except you'll notice instead of x bar, now we've got mu, right? And here, instead of x bar, now we've got mu. And instead of n minus 1, so 1 less than the sample size, here we just want the actual population size. And then for population standard deviation, again, that should be a capital N. It should just be the square root of this guy up here, but it's the same idea. Okay, these are the same formulas. It's just whether you're doing a sample or population. The only thing that really changes is the sample size minus 1 over here, or the population size over here, and you don't subtract 1. That's really the only thing that's different. So let's do an example. We're going to talk about this where it says the difference between, so the name deviation is just when you take each x and you subtract from it the mean. And that's true whether you're doing sample or population. And then these are all the formulas that I gave you for population and standard deviation a second ago. Now, here's the point. Observation about standard deviation. So here's some things to remember. Standard deviation is a way to describe how spread out stuff is compared to the average. So all this is about how far away is it from the average, okay? How far away the data is from the average. Remember, range just, highest to smallest. Standard deviation is how far away is the data from the average. And when standard deviation is always greater than or equal to 0. If it's 0, then there is no variation, which means every answer in there is the exact same answer. Like if you said, how many pair of shoes do you have? And you asked 50 people and every single person said, I have 3 pair of shoes, then that standard deviation would be 0, okay? And as your answers or entries get farther away from the average, there's the value of that standard deviation is bigger. So the more spread out it is, the higher the standard deviation. So here's the idea of what you're going to do. This is all on one slide. It'd be smart to have this stuff written down in words and in symbols. So first you're going to do is you're going to find the average or the mean. Then you're going to take each value that you got and you're going to subtract from it the mean. Then you're going to square all those. Then you're going to add up everything you just said. Then you're going to divide it by the population size. Then you're going to take the square root. Okay, so these are the steps all in one slide in words and in symbols, and then we're going to do an example. So if we go to that corporation salaries, and we just look at corporation A, we find the population variance and standard deviation of those salaries in corporation A from that first example. First, we have to, step 1, find the mean. And this is a sample mean, right? This was a sample. Sorry, my bad. This was the whole population. This was everybody's starting salaries. And so we're going to use the mu. So we add up all those terms. We add up all those x's. We get 415. We count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. So that's our samples or our population size. And then we divide that. That tells us our average, our mean, our population mean. So now we're going to use this mean and we're going to subtract 41 minus 41.5 and 38 minus that. That's the next step. So step 1, find the average. Step 2, subtract. So these were all the answers, right? So now that we know our average is 41.5, we're going to do each of these minus the average. So 41 minus 41.5. 38 minus 41.5, get an answer. And then you're going to keep doing that all the way down, okay? So now these are what we call the deviations. Okay, that just means how spread out is the data from the average. And you got to add those up. Add those up, 0. All right, here we go. So step 1, find the average. Step 2, subtract each of the data minus the average. Step 3, square all those answers. So I'm going to take this answer, negative 0.5, and square it. Then I'm going to take negative 3.5 and square it, and then keep going all the way down. Once you square all those, you add them up, and you get this, what they're, the sum of the squares of the x's. Sum of the squares of the x's, right? Sum of the squares of the x's. So in this case, it's 88.5. So again, step 1, find the average. Step 2, subtract. Step 3, square it. Step 4, divide what you just got. Well, my bad. Square it and then add them up. The next step is then you're going to divide by the population size. In this case, that was 88.5 was the sum of the squares. And then you divide it by 10. There were 10 data entries, so we get 8.9. Step 5, take the square root. And that gives you the population standard deviation. So our final answer here, the variance, they asked for that, and it was 8.9. It doesn't really tell us much. We can't really talk about units and population variance, but you can when you get to standard deviation. And the standard deviation here was about 3.0 or about $3,000. So kind of think about it as each group goes out about $3,000 from the average. Okay, next example. Ooh, football, right? In a study of high school football players that suffered concussions, ouch. Researchers placed the players in 2 groups. Players that recovered from their concussions in 2 weeks, 14 days or less were in group 1. The ones that took longer were in group 2. So we have 2 groups, 2 samples, and they're asking about the recovery times in days for group 1 are listed below. Find the sample. Now we're using sample this time because it wasn't the whole group. It wasn't all the football players. It's only from group 1. Find the sample, variance, and standard deviation of the recovery times. Okay, so our step 1 is going to be find the average. Okay, now this time I'm not using the mu symbol because it's a sample, right? We use X bar for sample. So find the average. So add them up and divide by how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12. So we're going to add all those up, divide by 12, we get 7.5. That's step 1, okay? Step 2, take each of those answers, each of their recovery times, and do that number 4 minus the average, which remember we said the average was 7.5. So we're going to do 4 minus 7.5, we get negative 3.5. 7 minus 7.5, we get negative 0.5. 6, et cetera, et cetera. And then square all those answers. Okay? Step 2, subtract. Step 3, square them. Step 4, since we're doing a sample this time, we have to divide by the sample size less 1. So we'll have to do the sum of all those squares we got was 39, and then we're dividing by the sample size minus 1. So there were 12, so we're only going to divide by 11, so we get 3.5, and then we're going to take the square root. Okay, so I mean that takes a few minutes if you're doing it by hand. The final answer, sample variance, is about 3.5, and the standard deviation is about 1.9 days, so almost 2 days. Now, that's not the average, right? Average is different. Average we found earlier, and it was 7.5. But there is a trick and ways to do this on spreadsheets and calculators and all sorts of things. So that's what I'm going to talk to you about right here real quick. This is about renting offices in LA. Okay, but the idea is to use technology to do this. And now I'm going to show you how to do this on technology, but we're not actually going to do this example. So you could use what's called Minitab. You could use Excel. You could use TI-84 Plus. You could use Google Sheets. You could use all sorts of different options. But the one that I'm going to show you right now is on a TI-84 Plus calculator. So the good and the bad about this is that I can't hand you a TI-84 calculator, but your computer already has one in it. Okay. So on your computer, when you turn it on, there's a tile that says TI Smart View for the TI-84 Plus family. And you open it the first time and it takes a long time to load it. But once it's loaded, then it's not that bad. And so here are the steps that you would type in to use the TI-84 on your computer. You would hit the Stat button, then you would hit Edit, then you would type in the values into the list 1, and you would hit Stat, you would arrow over to Calculate. Then you would pick this option and then hit Enter, and your screen would look something like this. Now, I'm going to push pause for a second, maybe. Okay, so once you open up the TI Smart View, you can make it look lots of different ways. This is one way. If you just push to different views, make this, there's stuff on the right side. If you hit this, it'll record every button that you push, a history of it, that kind of thing. I'm going to hit clear, and I'm going to clear that history. Yes, clear the history. And I just want it nice and simple right now. So I'm going to try and get rid of all that if I remember how. Let's see. No, I don't want that. No. That just makes, okay, so this is the output screen, and then these are the buttons you can push. And on TI-84s in general, you can't click on the screen part and it do any good because they're old. You have to click on the buttons, and that's what you have to do for this. So let me pull up these instructions again, okay? So as a quick reminder what this would look like then. Once you've got it open, if you hit Stat, which I'm going to make this a little bit bigger so you can see a little bit bigger maybe, maybe not. But Stat is right here. Okay, so I hit Stat, and then see where it says choose Edit. So I'm going to pick number 1. I'm just going to hit number 1. And then it says type the values into list 1. So I'd have to type in all my values here. And I don't remember what they were. So we'd have to go back and see that. Let me see that real quick. Go back to those values. There they are. There's the values. So I'm going to have to type those in over here. So I got 51, 51, enter, 47, enter, 33, enter, et cetera, et cetera. Okay. Now I'm not actually going to go ahead and finish all these. I'm just going to do a few of them. You should go ahead and do that though. So that you know that you get the right answer when you do this. Because when you get through here, this should be your answer if you did it correctly. And again, the steps are Stat, Edit, type the values into list 1. Okay, I typed them in. Then I need to hit the Stat button again. So Stat button again. Then this time I'm going to arrow over to Calc. You see where it says Calc up here? So to arrow over it, I'm going to hit these little arrows to the right. So arrow over to Calc, and then pick the first one variable stats. So number 1, choose number 1. And then yes, I want to tell it yes. So I'm just kind of going to hit enter until it does what I want it to do. And then there we go. And so when you get this, you'll notice that this top thing tells you the sample statistic mean, your sample mean up here. This one tells you the sum of all your data. This tells you the sum of the data once you square it. This right here is your sample standard deviation, and this is your population standard deviation, and this is the number of pieces you have. This is your lowest value. You could arrow down and it will tell you your median, it'll tell you your highest value, all that kind of good stuff. So this is a quick way to find the sample mean and the sample standard deviation, or if it was a population, the population standard deviation. Okay. Helpful stuff on your handy dandy computer that the school handed to you. And if you forget where that is, when you open up your computer, you have those tiles. The TI Smart View is one of those tiles that you can select, and that'll open this up.